sun is by far our best resource. The Earth gets enough energy from the sun in 1 day to power the world for a year. But there still seems to be this debate over which form of renewable energy we should turn to, which one's the best. But if we can harness even a bit of the energy we get from the sun, we can power the world many times over. But for this to be realistic, solar needs to get quite a bit better. Firstly, the current technology we're using isn't more efficient, and these solar panels have reached a ceiling in which the technology isn't going to get much better. Secondly, I think we're all aware of the concept that solar is quite expensive. And third, and in my opinion, the most overlooked issue is that we're using a ton of space to install this technology that simply isn't getting any better. But what if we could harness existing infrastructure, such as the windows on skyscrapers, to create cost-effective and efficient solar panels? This is what quantum dots can do. Quantum dots are the product of integrating nanotechnology into solar. And when I say nanotechnology, I'm talking a scale of tens or hundreds of atoms. A quantum dot is a semiconductor nanoparticle that is 1/10,000th the width of a human hair. Now, this is an existing technology. Companies such as Samsung are making TVs out of quantum dots, and that's because when you put energy into a quantum dot, it releases light. And so this makes, for example, a great TV screen. Now, because quantum mechanics is linear, when you put light into a quantum dot, it releases energy. And this is how solar quantum dots work. So you can apply quantum dots to glass or another substrate, such as what they've done at the Michigan State University.
What we're going to do now is just hook up the solar concentrator, and we're going to shine the light.
But you can also
the active
apply
layer,
quantum dots to existing solar cells to increase their efficiency.
Generating power.
But how exactly do these quantum dots make transparent solar cells so efficient? And to understand this, think about how much more efficient we could be if we could effectively multitask. Current solar technology only uses a sliver of the light that we get from the sun, and this is visible light and a bit of infrared. And so they can't multitask. They're set on this very specific wavelength range. Now, quantum dots, on the other hand, absorb ultraviolet light and infrared light while letting the visible light through, so it can still be a great window. And they do this because when you change the size of a quantum dot, you change the wavelength of light that it absorbs. You change its band gap, which allows different wavelengths of light to promote a whole electron pair to the conduction band, and depending on the size of the quantum dot. But that essentially just means that when you change the size of a quantum dot, you change the wavelength or the color of light that it absorbs. So when you layer several different sizes of quantum dots onto one substrate, you can now absorb whatever wavelengths of light that you choose. In other words, it can multitask. And this allows the efficiency of quantum dot solar cells, while being transparent, to be 30% higher than the solar cells that we're using now. So I thought, if these solar panels are going to be powering the world using the infrastructure we already have, and it's going to be cheap and it's going to be efficient, this is going to be a big deal. So I want to make my own quantum dots. Now, unfortunately, you need a lot of specialized equipment and materials to make quantum dots, but I thought that was dumb, so I made them my own way. And the end goal was to have quantum dots suspended in a solution, and you knew that they were there if they fluoresced under ultraviolet light. And I was trying to make orange quantum dots. So I essentially just mixed 85% phosphoric acid, water, table sugar, and 50% sodium hydroxide. And the first result looked not quite what I wanted it to be. It looked like this. These are obviously not quantum dots. But from there, I refined my process, and I threw out the UV light that I made myself, because that wasn't going to work. And I finally had success. And these are orange quantum dots. Now, the next step for me is to apply quantum dot technology to solar, because alone, they just fluoresce and kind of do nothing. So in order to do that, I was ready to go, and I ordered my solar panels off of Amazon, but I don't have a high-pressure vacuum chamber. So I reached out to somebody that I was in touch with at the University of Waterloo, and they offered me the opportunity to work in a lab there, which I'm going to be doing in a few weeks. And also for the month of June, I'm going to be working at AMP Solar in Toronto. Now, I'm doing all this work with solar and nanotechnology because I know that if we can make solar panels cheap, efficient, while using infrastructure that we have now, this is what's going to power the world. Thank you.